Well, hello everyone. Hello. Welcome to the AI Native Telco Forum 2025. Come on in. Please grab a seat before they all disappear. I've never seen so many of you before. That's fantastic. Please come on in. We're going to start right now. So please find yourself a seat. You'll be pleased to know that it's almost time for our first session, which, as you can see, is entitled AI for Enhanced Network Capabilities. Quick note about these sessions, because these are new to us and to you. They'll mostly comprise of 2 presentations, 10 minutes each, followed by a quick Q&A from the audience. So, we do have some roving microphones. You do have the opportunity to ask our presenters a question or two. That's the plan. I think we'll get more questions or calls for questions than we have time for. So I would ask that you please use the networking breaks to follow up any questions you have and just keep the conversation flowing across these 2 days. So our first speaker is Ahmed Hafez, who is SVP Network Strategy and Data and AI Networks at Deutsche Telekom. Now, Deutsche Telekom is the CSP co-host for this forum, and we've been really thankful and appreciative of the support they have given us. But before we hear his presentation, we should mention that Ahmed is the reason we are here today. And I'd like him to come up on stage and have a quick chat with me to explain more. Ahmed, come up on stage.
Great. Sit here or sit here?
Oh, anyway, what?
Okay, so not to be too close.
Not too close, not too close. We're socially distant, aren't we? I'd just like to take you back before you give your presentation, because it was DSP Leaders World Forum last year, so 2024, just over a year ago, when you presented on the AI native. And I think at the time, certainly for a lot of us, brand new, totally new concept. There'd been a management report, a consultancy report, I think, about the general idea of being AI native. So what was it that resonated with you? Why do you say, look, this is a really hot, important area, crucial area that we need to focus on?
Right, so first of all, welcome everyone to Düsseldorf. So it's really happy to see you all here. I'm saying welcome because I'm living in Düsseldorf, so it was great that the forum comes. Back to AI. Actually, from early 2024, even before that, even in 2023, we started realizing the waves that are coming with AI and how AI is developing, and there was a clear opportunity for us to consume. So there are, wherever you look into networks, whether you look into network lifecycle or you look into the daily jobs that we do, AI can play a significant role. We do a lot of, if I may say, tedious things that do not require really human intelligence. So the first observation was that why don't we use AI to actually do these tasks that are repetitive and quite boring also for experts and engineers. Then AI was developing as we speak, and we were actually as we try to do something else comes in. And we started to see there is a chance of being overwhelmed with what's going on. And we had 2 choices. Either we wait and see, so sit back, and I know that many have done that, or we actually get in and learn by doing. And we chose the second. So we got in and we started learning by doing. We actually changed courses of things that we approached. We took approaches that we stopped, and then we took a different approach. So we had to adapt. And back then, when I started the discussion, when we discussed to bring the topic in, so I thought, this is going to be the topic of the next era. So we need actually to start talking about AI and deepen our understanding and together share our experiences, because I think this is something that no one is enough to do. And really, we would have to be humble around AI. So AI is actually all over the place. There are so much developments that no one can actually manage alone. So it's actually the source of information when it's spread across and when we share, it's actually good for everyone.
Now, I mentioned earlier that there's this expectation that we all know what the AI native telco means, and maybe it's because of the rapid advancement of the LLM side of AI that we've just got so much knowledge on it, or news about AI coming at us from all sides. Do you think we really do have a clear picture of the AI native telco?
Right, excellent question. So there's no definition of AI native networks, but what I can share is my perspective on that, so take it as mine. So of course, as we said, we stay humble, it's just an opinion. So if you look from the stack that we deal with, an AI native network for me starts from data that is actually generating data that is consumable by agents. not only by human beings. We had a lot of discussions with suppliers that the way they describe their attributes they do in log files, in alarms, and other things is for human consumption, requires a human behind. We need that to be agentic friendly, agentic ready. So it should be described well enough in order for an agent to interpret this alarm or this log file or whatever data is. The data also should have certain level of curation at the source, because it's too expensive to collect petabytes of data and then try to clean up data. We need the data to be started cleaned from the source, meaning that at least the basic rules of checking whether this record is valid or invalid can be done, so we can actually filter. So this is just a data layer. Then you go the next step. When you talk about a AI native network, so is the network having the right bolts or the right connections and interfaces for AI to create closed loop automation? Is it done? I mean, you have, of course, we're building the networks with a lot of resilience from day one. Without AI, we had always rules and policies that would maintain that. But we need something that would connect back to the network. Then you go further. How can we deepen AI inside networks? So the networks, not only that on the top, like OSS layer, and then we pull data and then process and go back. How can we embed AI within the networks itself so it becomes deepened inside the network functions, not outside the function, but inside the function? Then you start going into different aspects that are related to, if I fast forward, because I don't want to prolong that, the intent-based. It is intent-based from an operational perspective and intent-based from a customer perspective. So you can actually have the intent in operation, say, I want to optimize, this is what I need, and so on, and the network can deal with something like that. And then you go to customer intent. So I want to make sure customer experience or customer is demanding certain experience, and then you translate that into what does it mean for technology, what does it mean for implementation. So we have quite a long journey to get there, but I think if we don't start now, we will never reach it.
Absolutely right. We have to start now, and you just articulated very well what we expect to talk about and discuss, and why we need forums like this to discuss, and then actually get on and implement. So that's a great scene setter for the forum. I'm going to invite you to the lectern because we'd love to hear the opening presentation.
Right, thank you.
Please.
Right. Accelerating AI in networks. So my presentation will be focused on networks, so it's not generic across everything in telcos, so it's network-centric. And I would start here with the latest MIT report that went out and said 95% of companies cannot really reap any value of AI. They're still investing but not getting the value. And before I judge that, I will just want to share with you the first thing is that the value is not only in productivity and TCO. I would actually start from customer experience. AI can actually create exceptional customer experience, even if it does not save you money. But this is a return on investment. This is a big return. This is not something to consider it as a side thing or a byproduct. It's a major outcome of AI. Then time to market. Definitely, we do a lot of things that takes us months. It could take us weeks or minutes. I mean, in our team, we created something on data pipeline automation. Instead of taking weeks, now it takes 1 minute. So this time to market, even in project execution, is extremely important, and its value. Whether you can render this value back into money or not, this depends on the area and depends on what you're doing, but its value in its own. If I do a project now, instead of doing it in 12 months, I do it in 3 months, that's a big value. Of course, TCO, so front and center, so that's why it's in the middle, so that yes, of course, TCO is very important, and every one of us is looking into it because we want to make sure that the industry is more efficient and sustainable. But also enhancing network resilience. I don't see a lot of people talking about that, but actually we're a critical infrastructure. We need to care about resilience, meaning our network is robust against issues, security hazards, attacks, even outages. We need to be resilient enough. And if you want to be resilient without AI, it would cost you a huge amount of money. And it's sometimes prohibitive. So AI can solve this kind of balance between, I want to invest and get resilience, but not invest too much for resilience, because maybe that's too much. No, I can actually do what I want to achieve, but with AI. So this is also, again, even though maybe you're not reaching the resilience today, so you put AI, you reach a higher resilience, you're not saving money, but you're creating a lot of value So the return on investment is not only TCO. And finally, of course, AI would enable new business models, new services, new capabilities, and then you can launch things and then also get revenues out of it. So AI is really of a huge potential. So despite being overwhelming, moving too much, it is the right path to take. I want to give you just a glimpse on our networks, just focus on networks, on use cases. I mean, it's not the best measure because the impact is the best measure, but I would say, just to give you a glimpse, how things were evolving. Back in 2024, we had round up, I'm not putting the numbers intentionally, but I can tell you the numbers, like 150 use cases across networks. That was predominantly predictive AI. Back then, we said, okay, predictive AI is very strong, it's very important, it will continue to be the core. And then as we evolved, said, but the scaling of generative AI use cases actually is going faster. And we can actually leverage it faster. So you see, a year later, the growth in generative AI was staggering, was the highest. And we also jumped into agentic AI. As we said, we are learning by doing. So we learned a lot across this journey. And I will share with you later. I hope I'm not taking so much time. Just warn me if I'm taking so much time. So we learned a lot by doing. Then we try to classify things because we also realized that the industry is using the word agent everywhere. So we try to maybe discipline ourselves first before anybody in order to have the nomenclature correct, at least in our perspective. So we have 6 tools, starting from rule-based. The rule-based, everybody knows. Then you have the predictive AI, clear. Then you start with RAG chatbots. So we put chatbots and RAGs together in one element. This is where the generative AI starts. Then there is a step that's always confused as an agent. We don't call it an agent, we call it co-pilot. This means that you have generative AI, but always a human sitting behind it. So humans triggering it every time. That's a co-pilot, that's assistant. Not undermining it, it's very important, very critical, but not an agent. Then we go into single and multiple agents, and then where this is something that you can trigger by any means, not by a human necessarily, that would be an agent that you can trigger automatically or in cycles, and then that agent starts actually to do the job, finish the job, maybe communicate it to a human or to another agent. So this is how we, in Deutsche Telekom, classify the 6 tools for AI. And rule-based is still considered intelligence, even though you can argue, but we put it in the tool set. Why agents? Very quickly to mention a few things about traditional automation before agents, before intelligence or generative AI in general. The point here was that automation is usually static. Take the example of the CPU load. You can, of course, put a very good rule and say, if the CPU load exceeds 85%, stop tracing, stop reporting, stop site functions, and if it exceeds 95%, you start blocking new calls to make sure that you don't go into cyclic restarts and then you render the network off. You all know about that. So, but what happens in reality is that you have spikes in CPU load. The CPU load can go above 85% for 1 second, for 2 seconds. Do you want to trigger the stop of the tracing? And then after that, you want to see, okay, after a while, you bring it back, or what do you want to do? So it's not intelligent enough. But if I have an agent and say, monitor the CPU load, if it persists for some time over 85%, you can stop tracing. But so I am flexible to give it time and thoughts to look and monitor and judge. Because if it's 86 but it's going down, it will not stop tracing. Keep it. But then it has the intelligence to see what's going on. So it's dynamic, it's not static. Then lack of context. Lack of context is a very interesting angle, is that, take for example, a very simple example, microwave links. In microwave links, you can, with predictive AI, predict, is the problem weather, is the problem trees, is the problem something else, and so on. Yeah, of course, you can add more information and get more information. But if you deploy agentic AI, the way you would deploy it would be different, because you would say, OK, I will grab the information of that, even of predictive AI, and then I will look into the weather forecast and the weather today and now in that point, in that situation. And the agent would verify the outcome of the predictive AI, say, yeah, it's really a weather problem. It's an issue. No, it's a fire, not weather. It's a fire in that place. So this you cannot get with predictive AI, but you can get it with agentic AI. So the context, what's going on. then the other one is reactiveness. Of course, this is what differentiates agents. Agents can be proactive. They can monitor and take action, so you don't have to trigger them. And this is very important if you talk about autonomous networks level 4 and above. And then being prone to errors is another dimension. Of course, agents as well as prone to errors. But agents, you can verify and review what they do. When it comes to rule-based, complex rule-based, that is 2-3 pages long, usually, and correct me here if I'm wrong, the ones that have developed it are the only ones who can change it. It's becoming very complex. See if they retire. You would let this rule run until it crashes, then you have to remove it. No one can maintain it. And to decouple, I mean, what is this if, and then goes here, and then, but what happens if that? So this becomes complex. So just to give you a few examples of what we have used for AI, these are just examples of some numbers we have achieved. And I will talk only on the first one, RAN Guardian, in the next minute. So RAN Guardian, what is RAN Guardian? RAN Guardian is a multi-agentic AI that is actually will be launched this month. So we are actually working on it since before MWC, and now we announced it in MWC, and we're launching it this month. And the RAN Guardian is actually a system that is self-healing. It is monitoring what's going on. It's understanding the user experience and seeing if there are high utilization in cells because of events or because people are more coming. And then they tune the configuration of the network automatically to match the people that are coming. So it monitors what's going on in the networks. If people are going to be gathered, it prepares that, it verifies things, and verifies if the alarms that are already being generated are correctly prioritized or not. So for example, there's a concert, and we know there's a concert happening, so the AI knows, it will know that there's a concert happening in Germany, in this place, and then it goes check the alarms for the associated sites, and then if the alarms are low priority, it lifts them up to higher priority. Because even though they're not creating problem now, when people come, it will be a problem. It could even render an outage. So then it takes that and it processes that and makes the engineers process that as fast as possible before the event happens. And during the event, it cycles and checks the KPIs, and accordingly, it triggers actions automatically. And these actions are triggered, except two of the actions requires human intervention, and this is a design choice. So we decided that only 2 would require a human in the loop, while all other actions that are taken on the configuration are safe enough to do, so agents take decision on their own. I'll show the video and I'm done. So if you can show the... Actually, the final result was that usually if you want to manage an event or so, our engineers takes 45 minutes. Now with the AI, it's less than 1 minute. So even it's not 60 and 20, it's actually 45 to 1 minute. So thank you very much, and thanks. I'm done. So,
absolutely fantastic. Really, really fascinating. Come and sit down with us. Great presentation. Fascinating insights there, and some interesting developments to watch out for. There's a lot I took from that, but I'm sure there's the audience maybe have a question or two. We do have a couple of roving microphones. You'll have to excuse us. The lights are quite low here, so it's hard to see you all. But if anyone wants to put their hand up and ask a question, we can do so. In the front row, Francis in the front row. There's a microphone on its way to you. Hello, Francis.
Thank you, Ahmed. Francis Haysom from Apple Door. I'm just interested in, this is really exciting, but how are you dealing with the issue of trust? You mentioned that rules-based, only the the person who coded it knows what's in the rules, but you can read the rules. A lot of this is hidden, a lot of this is black box. How are you dealing with trust? And what are actually considerable changes on the network? But, last week, for example, we had the Vodafone network go down, probably not for a configuration reason. How are you dealing with that trust aspect and actually verifying that you're making the networks more stable rather than...
Excellent question. So the trust has many facets. So I would start from the transparency. So when we code, the agents have thousands of lines of code, not only prompts. So it has codes that would govern its movement, and you would have to give them very clear instructions. That's the first step. Second step is that, of course, after testing and all that story, we did something which we actually limited the span of impact. What does that mean? I would give you choices, like 10 choices. You cannot choose choice 11. There is no choice 11. You just don't do anything if you can't choose one of the 10. So the damage it can create is 0. It cannot create any damage because any of the 10 are safe. So they, of course, would impact slightly the user experience, maybe a little bit that could be better configuration, but that happens in any case. So what we do is that we protect from any damages by this kind of limitation. Then there is something very important in general when it comes to agentic AI. When we started the journey, we learned a lot. We realized we need guidelines on how we operate agentic AI. And of course, we need to monitor exactly what's going on. Log everything that is happening, understand it, and even deploy AI to verify what's going on, to make sure. So we have humans managing the agentic AI and looking into the results. And you can stop the agent at any point. If there's any issue, you can stop and take over. You can actually look into if the agentic AI is doing it well. And we're also doing kind of a closed loop learning because the agent logs when something happened, it logs what happened and the result. And then if the result is actually good enough, then it can use that for the next time. Instead of iterations, I can actually jump into that target configuration because exactly the situation is the same, so I can use it. So these are just a few things, but the topic is much bigger than that. But there's just a few hints.
Thanks very much, and great question. Thanks very much indeed. I'll tell you what we'll do. We'll invite our next presenter to come on stage. Have the next presentation and then see if we get some more questions at the end. So Clay, I'm going to ask Clay to come on stage. Please, round of applause for Clay. Clay Simmons is Vice President, CGO, Chief of Staff at Supermicro. So I shall leave the clicker to Clay.
Yeah, thank you. Appreciate it. Great presentation prior to this one, Ahmed. This is a great dovetail. So I'm actually going to share 8 different areas in which Supermicro is engaging carriers, is engaging our partner ecosystem, and is also engaging the AI RAN Alliance on how we're making improvements in RAN with AI. So first and foremost, I think we can all agree that RAN is probably one of the most sophisticated, complicated systems that man and woman have ever created in our entire lives, right? When you talk about RF propagation, modulation schemes, and transporting layer 3 commands and protocols on top of that, it's extremely complex. But I think we can also agree that it can actually be improved significantly. And I think, and the industry thinks that with AI, these improvements can certainly present themselves. So I'm going to share with you 8 particular areas that we're focused on and supporting, our industry ecosystem. So first and foremost is beamforming and massive MIMO. These are very complex with regards to how these antennas are managed, directed, and how they're propagating the RF. But with the various layers, especially in extremely dense urban areas, the interference is incredibly intense in these environments. And so deep learning obviously can improve and enhance the way in which the engineers manage these radio frequencies and propagation. Another is, to Ahmed's earlier presentation, is the predictive resource management. So it's really about how AI can forecast traffic, optimize spectrum use, and ultimately reduce energy in the process. The third is the development of the systems, the expansion of the radio access networks in new markets, and how carriers can leverage using new models, using digital twins to support smarter and better deployments. And the fourth is fault detection and root cause analysis. In fact, I just had a conversation with a large carrier in the Nordics that they're doing just this. They're leveraging AI to predictively determine what their maintenance for hardware and software is on their systems. Shifting to the next slide. The next two get a little bit more complex. This is talking more about intelligent network optimization. So what many of you know as self-optimizing networks that we have today. But in this particular case, it's doing this dynamically with AI, using real-time parameter tuning and managing the coverage, balance, and anomaly detection. And then also applying AI into the RICs, the RAN intelligent controllers. Both the AI-driven XApps, so more real-time network modification, and also the larger data-intensive RRAPs for enabling that closed-loop automation and cross-vendor optimization, which is quite interesting. I think Ahmad brought up a really good point. Today, the self-optimized networks are rule-based, right? Rule-based is not artificial intelligence. I think we can all agree to that. And so when you have a rule base, these rules apply specifically to the experts that developed it, as was previously noted, and also specific to the vendors that actually deploy it. But with AI, it becomes a lot more extensible. It becomes a lot more open. It becomes a lot more available for carriers to take ownership and for it to be more interdependent in the other functions of the carrier's operations. And then the last two are quite obvious, right? So security, being able to detect threat and anomaly detection earlier in advance, being able to adapt to those defenses and making the necessary choices dynamically without human intervention. And then the last, of course, we wouldn't be here without users and their ability to purchase and consume and enjoy the services that the telco industry provides. So quality of experience is extremely important, and how that is tracked and monitored and how it's adapted based on the limited resources that the operators have is extremely important, and I think AI can play a massive part in that as well. So I want to double click on a couple of these that actually my solution architects helped me build. And one is the predictive resource management. And this is a very simplified slide to a very complex situation. But basically, this is about how carriers can basically turn radio functions off and on. And they're already doing this today in obvious time periods, like in the middle of the night. In this particular time scale, the x-axis being from midnight to 11:59 p.m. In the middle of the night, you might have improved resource management to where you might turn some radios off from say 12:01 to 2 a.m. and then say from 2 a.m. to 4 a.m. you might actually turn just one off. As you can see, there's a little lighter squiggly line that determines the expected KPI. But when we turn these off using AI, it doesn't really change the KPIs. And this is a pretty simplified model, of course. But if you can think about not just looking at it from a time basis, but looking at it from a market basis as well, how might you be able to manage the resources both in an urban or in a rural area, right? There's opportunities there to modify not just the time, but also the geography of where these resources are applicable. So, with scalable AI, meaning that it scales both, depending on the deployment location, whether it be centralized or at the edge. Against existing KPI rules, the radio resource management can ultimately be improved, and so in turn can also improve overall both the human resource that's applied to it, along with the energy power management that's applied to it as well. And then the last use case I want to talk about is the intelligent network. As I mentioned before, self-optimized networks are rule-based, right? And so that's not artificial intelligence, but there is an opportunity for artificial intelligence to play a much larger role in both the service management orchestration and also the radio access network intelligent controllers, to whereas today, instead of rule-based, you actually have more of a dynamic approach to where the AI hardware and software is continuously monitoring a closed loop, the data collection and the process across both whether it be central or at the edge to meet the performance metrics, as I mentioned in the last slide, that are already established by the operations of the network carriers. So through this closed loop intelligent parameter tuning in real time, you get the very best operational output against the resources that the carrier has. So in conclusion, today, as I mentioned, we have, semi-automated self-optimized network and traffic optimization, mostly vendor-specific and traditional network equipment providers. They have been very successful in providing energy reduction and some basic automation, right? But it's still rule-based. I would say in 5G Advanced, we're gonna be focusing more on that closed-loop optimization via the RIC and the SMO, and will be reinforced with both deep learning and edge AI, and a lot of the traditional network equipment providers will begin to adopt some of this, but then also we're having our own equipment, and NVIDIA has their software in many of the labs within the carriers on how we go from where we are today to where we have self-optimizing radio access and predictive energy control. And then lastly, future 6G, where we have fully autonomous self-learning radio access. It's federated, so it's highly extensible across all the different functions of the carrier's environment, and it's self-evolving, so it's self-learning. It's completely closed loop. So it becomes a true native AI RAN that both scales, right fits, based on that specific KPI of both the carrier and the market that carrier provides. So zero-touch operations, 40 to 60% decrease in OpEx, and ultimately lowering energy cost and CO2 emissions comes along with that. Improving faster network adaptation, and ultimately improved quality of experience for the customer. Thank you. Appreciate it.
Yeah, thank you much indeed. Come and sit down with us. Great, thanks so much. Anyway, sit, that's fine. Great presentation. Thank you so much for that. Do we have any questions from the audience for Clay? Otherwise, I'm going to start off with a question. I'm going to sneak a question. Well, Clay, I'm going to sneak a question in there. You identified 8 areas, as we just saw. From your conversations, do you see commonality between telcos on how and where they are either deploying or plan to deploy? Is there consensus, or is it on a case-by-case basis?
Yes and no. It is on a case-by-case basis. I think there is some, I would say, low-lying fruit that, back to Ahmed's point earlier, where you have somewhat redundant processes, right, that are uninteresting, I think, from an engineering perspective, but yet still problematic and need to be addressed. We're seeing the telcos address some of those, even right now. And we talked about predictive maintenance schedules and things like this, predictive, being able to predict improvements. So we are seeing that. We're also seeing a lot of lab work across. I mean, it is becoming very ubiquitous, where we have a lot of our hardware and mini labs that are doing this kind of evaluation, right, at the radio access level. And we're also working with the network equipment providers, so the likes of Samsung, Nokia, and Ericsson, right? And they too, right, are also exploring these areas very closely, and we're working very closely together. So I would say that we're in different places, but we're all moving in the same direction, if that makes sense.
Does.
Yeah.
Clay, thanks very much. Just seeing some more questions. We know we have invested in 2 handheld microphones, so we've got to use them. So please, let's put this to use. If not, I've got another question, and Ahmed, I'm going to come back to you, if you don't mind, because you were talking in your presentation there about all these different tools and approaches and methodologies and definitions and nomenclature that we haven't maybe sorted out yet. And then we come on to agents and agentic AI. And yet, if you read wider into the AI sphere, not everyone agrees on what an agent is. There's different definitions, and it's evolving all the time. So you can't wait for definitions to suddenly resolve themselves. Can you? What's your approach to this ever-changing definition of AI?
Right, so rightfully so, we define things as we speak today, so as we see them today, and we refine them as we go. So what we decided is that we will go into the topics, we will work, we get our hands dirty with all the topics, then we adjust. And we adjusted a number of things. So we worked in paths that we realized the paths are not really rendering enough value, and we changed that direction. And I have to admit also, when we decided to move to agents at all, we realized that actually for networks, agents are the biggest value. So if I want to reach autonomous networks level 4 with minimum human intervention, there is no way that I can do that with a chatbot. That doesn't work. So we need to move to agents. And that's why we went there. And we define things so that we can work. Because otherwise, if we talk different things within one company, it doesn't work. So we used the same language, at least internally, with our suppliers as well. I think they also understand what we talk when we talk about agents. And then we moved on. If there is a better definition, we will embrace and update. So.
Clay, is that an approach you take as well? You kind of defining for what is here today, and as Ahmed just said there, if a better definition comes along or it changes, you'll adopt?
No, for sure, yeah. I mean, we're definitely in a state of iteration in AI, right? I mean, we're constantly iterating, and we're constantly learning from each other, which is great. In fact, I approached today as not as a presenter, but as somebody that's wanting to learn a lot, right, from a lot of the other presenters and just the collaboration, because we are. I mean, the industry very much is in a state of learning, and I do think that, and Ahmed is absolutely correct, right? Agentic AI, I think, is really, it's generative AI to the next level, right? And as agents begin to not just help solve problems, but also begin to communicate with each other, things get really interesting.
Great. Well, both of you, thank you both very much for the presentations and the chat. We will move on. So a round of applause, please, for Ahmed and Clay. Thank you.
Thanks, Clay. Okay, thank you.
Thanks, Clay.